Oh. Okay, so real quick, this is going to be a super fast crash course on graphing lines. But you probably already remember what to do. So I'm just going to do one of each different style. So number one is our easiest scenario where you have it in slope intercept form, y equals mx plus b. Remember, I always start at the b number on the end. So on the y-axis, right? So start at -2, and then I follow the slope. In this case, it's a -1/2. What does that mean? Where do I go from this point? If it's a -1/2, I go down 1 to the right 2. Always go to the right. A very quick check. Doesn't guarantee you that you're right, but if the slope is negative, your line should be going down from left to right. So if you look at your line and it's not going down from left to right, you already know that you messed up. Okay, so those are the easy peasies. Let's jump to something like 4. Oh, it's just a y equals. If you remember, oh, she taught us about Hoy bucks, our friends, our new friends. If it's just y equals, that means I'm dealing in Hoy land. That's funny. And then H stands for horizontal. It's literally just a horizontal line at 2. That's it. So if you have a look at your paper, if you did this already, if you put a vertical line at 2, I'm telling you, adopt the Hoy buck stuff. It really helps you keep them organized, and once you really know how to use them, you'll never get it wrong. Okay, jump to something like 5. This is in standard form. So I wonder how many of you took the time to rewrite this in slope intercept form. You can minus the 4x over, divide everybody by 3. You absolutely can. There's a faster way though. If you happen to notice, check this out. If these two numbers divide into that number, you can graph this by intercepts really nicely. Think about it. If you have a straight line, isn't it going to cross the x and y axis just once somewhere? So what I can do is I can plug in a 0 for x, which essentially just covers that whole thing up, right? If I plug in 0 for x, that is gone. And then wouldn't y just be 4? So I can literally just put a dot at 4 on the y-axis. And then I can do the same thing. If y is 0, plug that up. 4x equals 12, x has to be 3. Then I can just connect those two. Ooh, that was fast. Now, there are times where it's not so nice. Like what happens if you do that and then your answer is like 15 and that's off your grid? Well, now it's annoying. And there's lots of times where it doesn't go in nicely. Let me find one real quick where, oh, actually 6 is a great example. The 6, if I try that same thing, x would be -15. That's way off my grid. So what can I do? I got another thing I could do. Cover up the x. Y is going to be -5, right? Wouldn't y just have to be a -5? So I've got that point. And then once I have one point, if only I knew the slope of this thing. Do you remember the quick way to find slope if your equation is in standard form? Remember standard form is just ax plus by equals c. Remember how to find the slope from that? Anybody know? I know you know because some of you talked about it in like the first or second day of school. It's just -a over b. So in this case, -a over b, wouldn't that just be a -1/3? And look at that. So I already have 1 point. And now if I know the slope is -1/3, down 1 over 3. Hey, all I need is 2 points to create a line. That's enough. And if my paper was long enough, you could see, yeah, it does kind of line up that x would be crossing at a -15. It's just not on my paper. That's called graphing by intercepts. If you just plug in 0 for X and plug in 0 for Y. It just doesn't always work nicely, that's all. So there's a shortcut. If you want to rewrite it into slope-intercept form, you always can do that. What else have we got? So you hit one like number 11. This is not in any particular form. This is just sort of like, hey, I'm just some random line. So with this, I would just get it into slope-intercept. Why? Because I'm supposed to be. And I'm not that far off. I just have to divide everybody by 2. So if I divide all of them by 2, I get y equals 3 plus 3/2 x. But remember, we like the x term to be first. So I might just take the extra second to rewrite it. There it is. And now it's in slope-intercept. And now it's easy peasy. And I can do this all day long. Start at 3, up 3 over 2. Easy peasy, lemon squeezy. Let's see. Oh, let's do one that's kind of nasty, like 21. Looks daunting with all these fractions. I'm all about the easy life. There's an easy thing that I can do here. I would clear them. Clear them. I don't want to deal with them. They might come back a little bit, like my slope might end up being a fraction, but so what? As long as I have y by itself and I don't have a fraction involved, let's just clear it. I'm going to multiply everything by, what would my magic number be? 4. And I just want to reiterate, when you are going to clear the fractions, everybody gets multiplied by 4, even the 1 over there. That's been a common mistake. Jimmy? Oh, you want to do that instead? We can. Yeah, because then it would turn out y positive. Good idea. We'll kill 2 birds with 1 stone here. That's a horrible expression. But anyway, divide down, multiply up. That's going to now be a positive 7, right? So I'm going to get 7x. 2y, positive 2y, and then a negative 4 on the end. And now, yes, I guess I could graph by intercepts here. But as you can see, I know what my y would be. Oh, you could do that and then do the slope. Yeah, let's do that. See, if I insert a 0 for y, 7x equals negative 4, that's not a nice number, right? So I don't really want to deal with that. But if I plug in 0 for x, y is just going to be a negative 2. That's easy. So I know negative 2, I have a big old dot on my y-axis. So now I can just look at this thing and then figure out the slope doing negative a over b, because now I'm in standard form. So let's just do negative a over b, and that's my slope. So that'd be negative 7 over 2. That's not so bad, actually. And this brings me to another great point. If I tried to go down 7 and over 2, I'm off my grid. So 1, 2, 3, 4. What'd you say? Exactly. If I'm like 1 or 2 past my grid, I just keep going. But if I'm a little bit further than that, instead of going down 7 to the right 2, this is the same thing as doing the opposite of both. Let's go up 7 and to the left 2. So if I go up 7 and to the left 2, I'm still on my grid. Okay, double check yourself though. You know that the slope is supposed to be negative 7/2, isn't it still? It still is, right? I'm still going down 7 over 2. But if I can't do it on my grid because I run out of space, you can always just go backwards. You have to do the opposite of both things though. A lot of times kids mess that up and then they end up with something going up when it should be going down. So just step back and recheck yourself. Okay, I think I've done a smattering of each one. Are there any others that you have come across that you're like, I'm not really sure if I did that one quite right or not? No, we're okay. This is kind of old news. All right, so I would like you to try these for tomorrow, but gosh, let's make our lives easier though. On Jupiter, you could just open your paper up in the middle like this and just take one picture of the two inside pages. I don't want you submitting 4 individual pictures. You can if you want, but if you just do it this way, you can take one picture of these 2 pages and I'll at least have those 2. And that'll be enough for me. Does that make sense? So I do want you to try all of them, but on Jupiter, just submit these middle 2 pages, 1 picture, nice and easy. Make sense? I can always zoom in. So as long as it's clear and not blurring, or if you prefer to submit 4 individual pictures, you do you, whatever you want. I'm just trying to make your life easy. Questions? Yes. I do. On that cart in the jar, there's these protractors. You can use the straight edge side of that. Just the middle 2, but it's not open on Jupiter yet, so don't try. Give me just a minute.
And you need one?